Today we will learn about the heap data structure. So first of all, uh, data structure is a structure in which we store data, and heap data structure is a special kind of data structure which is used when we want to query the greatest element in case of maximum heap and the smallest element in case of the min heap, and we want the answers of such queries very quickly, that which is the greatest element among all these collection of elements, or which is the smallest element among this collection of elements. So the greatest element remains at the top in case of a maximum heap. So we just need to retrieve the top element and return to the user, which takes only O1 time, that is constant amount of time. So it is quite efficient for such kind of queries. Inserting, deleting, etc. are costlier than this kind of searching. So all other operations are taking okay times, but this particular kind of operation in which we want to search the maximum element, it is quite fast. So heap is used for storing data where the user wants to inquire for the largest element again and again. That is a lot of times. You will say we can use tree also for this largest element query. So in a case of a binary search tree, we are talking about a binary search tree. So the elements will be like this. So this will be the largest element of this binary search tree, and we have a pointer to the root. So what we need to do is we move right until we find a leaf node. So this is the largest element in this tree. So this kind of query takes time O log n in a tree, because the height of the tree is log n, but O log n is greater than O1. So a maximum heap is more efficient than a tree if we want to do such kind of queries, if we want to perform such kind of queries. That is the maximum element query. And similar reverse thing is min heap, which is used for minimum element query. Min heap is the more popular version. If somebody says I am using a heap without any prefix, then probably she is referring to a min heap. Okay, so now what we see is a structure similar to a tree. Actually, a heap is a structure similar to a tree. What are the constraints while storing data in a heap? Any element is greater than, we will see for maximum heap, and same applies for minimum heap also, reverse direction. So for maximum heap, what are the constraints while storing data? Any element has two childs at max, and both of them must be smaller than the element itself. Like 13 and 10 are the children of 20, so both of them must be smaller than 20. Similarly, 12 and 8 are both smaller than 13, 5 is smaller than 12, and 4 and 6 are smaller than 10. Similarly, this is the first constraint and the most important one. Okay, so we are showing the heap data structure in form of a complete binary tree, that is this kind of a binary tree. But while storing it, we will take the help of an array internally. So this is an array, in which we want to store the heap. And how we store it is like this: 20, 13, 10, 12, 8, 4, 6, 5. So these are the elements. So using one based indexing, in most programming languages 0 based indexing is followed, but we will use one based indexing for convenience. 1, 2, 4, 5, 6, 7, 8. So in this, if we want to go to the children of 10, then what we do is we just multiply 3 by 2. So 2 multiplied by 3 and 2 multiplied by 3 plus 1. These are the two children of this. These are the indices of two children of third element. So 6 and 7. So 4 and 6 are the two children of 10, which is actually the case. So if we store this tree looking data structure in form of an array, then if we are given index of an element, we can find the element indexes of its child elements by using this formula, that is 2 into x and 2 into x plus 1, where x is the index of the element itself. And similarly we can do for any of these. So why I was saying this is a complete binary heap, because there are no gaps in the array. That is, after 6 I am storing 5, and if I want to add a next element, I will add here, not here. So this place can't be empty. So while storing in the array, we store like this. This is in this fashion. Next time we will see how to insert an element in a binary heap. Thank you, friends.